NASA just launched a probe to the International Space Station to analyze airborne mineral dust and also to study the impact of it on the climate and environment of our planet. We know that NASA is extremely serious about exploring what lies beyond the Earth, but that does not mean that NASA completely forgot about the existence and well-being of our own planet, which is clearly evident from the fact that the agency will be using the data from the newly launched probe to study what kinds of dust will dominate which region and use that data to improve the current understanding of the Earth's climate system. So what exactly is this new mission all about, and how can it improve our future on Earth? Well, that's exactly what we take a look at in this video, so make sure to stick around till the end to know a lot more about this exciting new project mission from NASA. NASA is already collaborating with SpaceX to put humans onto the lunar surface. Apart from that, NASA is also working on several projects to learn more about our own planet other than the Moon or even Mars. Every year, strong winds carry more than 1 billion metric tons of mineral dust from Earth's deserts and other dry regions throughout the atmosphere. These winds are the reason why mineral dust is lifted from the Earth's desert, and as a result, the dust particles are carried to great distances all over the globe. Depending upon the color and composition, mineral dust can affect our environment in fascinating ways. Minerals containing iron also tend to be dark, and those with clay tend to be lighter in color. Scientists know that the mineral dust might affect the environment and climate, but they clearly don't have enough data to analyze in detail how these dusts can affect the Earth today or in the future. So, to improve the global science models and understand how dust heats and cools the Earth's environment, scientists are researching about dust's mineral composition as it blows around the Earth. That is the reason why Earth's Surface Mineral Dust Source Investigation, or EMIT, the EMIT instrument, exists in the first place, to help scientists unlock the existing mysteries surrounding airborne mineral dust and its effect on our planet. The EMIT uses the state-of-the-art imaging spectrometer that was developed by NASA's Jet Propulsion Laboratory, located in South California, which is responsible for collecting more than 1 billion dust source composition measurements across the globe over the course of a year. The project was developed by the EMIT science team, which consists of leaders in the fields of Earth system modeling, mineral dust aerosols, surface geology, and imaging spectroscopy. EMIT was launched on a SpaceX rocket to its destination on the International Space Station. It comes with multiple new advanced technologies, especially the Dyson spectrometer optical layout, which provides exceptionally high photon throughput, which means the optics maximize the light reaching the detector. The detector array uses new custom coatings to maximize sensitivity over the full emitted wavelength range. It has about 39 miles or 72-kilometer field of view, and across the entire field of view, the instrument has a uniform spectral response, which means it will facilitate the use of the most advanced data processing algorithms. The primary objective of this mission is to identify the composition of the mineral dust from its arid region. So for the first time ever, NASA's Earth Surface Mineral Dust Source Investigation mission will be comprehensively measuring the mineral composition of the Earth's dust source regions in order to help scientists understand not only the effects of dust on the temperature of our planet, but just about everything else in general. EMIT's scientific objectives are focused on understanding the heating and cooling effect, which is called radiative forcing, but its objectives don't end there. The first objective is to deliver a new, improved assessment of the heating and cooling effects of mineral dust in Earth's atmosphere. The second objective is to predict how future climate scenarios might change the amount and type of mineral dust emitted into the Earth's atmosphere. According to the current scientific community, desert regions produce most of the mineral dust, which then makes its way into the atmosphere. When EMIT maps the world's mineral dust source regions, this data will help scientists understand what kinds of dust dominate each region and will show us more details about the impact of dust on the climate and the entire Earth as we know it today and also in the future. As of now, scientists cannot confirm whether mineral dust has a cumulative heating and cooling effect on the planet. This is mainly because these particles in the atmosphere have different properties. Some properties may be dark and others may be white. The color of the dust is extremely important because it is what determines whether the dust will absorb the sun's energy, because dark-colored materials will be absorbing the sun's energy and light-colored ones will be reflecting them. If the dust absorbs more of the sun's energy than it reflects, then it will be warming the entire planet. This is the kind of information that would allow scientists to determine whether the dust heats or cools the planet overall. It also helps scientists to understand how the dust affects Earth's climatic cycles. Mineral dust particles vary in color, and that is mainly because they are made of different substances. For instance, dark red mineral dust gets its color from iron. The composition of dust particles will affect how they interact with many of its natural processes. In the absence of more specific data, scientists will be characterizing mineral dust as yellow, which is a general average of dark and light, and because of this, the effects of the mineral dust on the climate is not very well represented in any of today's computer models, according to NASA. EMIT will be responsible for providing a detailed picture of how much dust comes from the dark versus light minerals. EMIT will also be identifying the composition of mineral dust from Earth's arid regions, because desert regions produce most of the mineral dust, which later end up in the atmosphere. Most of the desert regions are very remotely located, which makes it difficult for scientists to physically go and visit these places to collect soil samples. So EMIT will be using the imaging spectrometer, which will provide information on the color and composition of dust sources globally for the very first time. This is the kind of data that is required by scientists to understand what kind of dust dominates each region, which will then accelerate the knowledge on the impacts of dust on climate and Earth that we know today. It will also clarify whether mineral dust heats or cools the planet, because as we mentioned earlier, scientists are completely clueless whether mineral dust contributes to the cumulative heating or cooling effect on the planet. Mineral dust also plays a huge role in cloud formation and atmospheric chemistry. This means that when mineral dust gets deposited in the ocean or forests, it can provide nutrients for growth, which then acts like a fertilizer. Let's say that if this dust falls on snow or ice, it will then accelerate melting of the ice, which will then lead to more water runoff. But for humans, mineral dust can be a huge health hazard, especially when inhaled. EMIT will be collecting information on 10 important dust varieties, which includes those that contain iron oxides, clays, and carbonates. This is how scientists will be able to assess precisely what effects these mineral dusts will have on our ecosystems. EMIT will also be improving the accuracy of the current climate models, because in the absence of more specific data, climatic conditions may not be very well represented in the current computer models that we have today. The color and composition information gathered by EMIT will change everything for these computer models. This means that when the instrument's data is incorporated into the existing computer models, the accuracy of climatic models will improve. EMIT is also responsible for helping scientists to predict how future climatic scenarios will affect the type and amount of dust in our atmosphere. We already know that global temperatures are rising and so many regions are becoming drier, which means most places will end up as dustier deserts. We are not quite sure about the extent of this, as it depends on several factors, which also includes the rate of increase in temperature, the use of land, and how rainfall trends change over time. So, by incorporating global dust source composition data into models and predictions that we have today, scientists will be able to understand better about the amount and composition of dust in arid regions and how it may impact climate in the future. EMIT will also be the very first instrument to use NASA's own imaging spectroscopy technology to comprehensively measure the mineral composition of Earth's arid land dust source regions. Imaging spectroscopy is also the same advanced technology that's used in NASA's other space missions. For each location in an image, EMIT will measure the spectrum of light, ranging from visible to infrared light, reflecting from the Earth's surface. The measurements will reveal several distinct spectral signatures of minerals in the dust source regions. Scientists will then be using these observations to generate new and more accurate mineral composition maps of Earth's dust source regions. It's crazy to think that something like mineral dust that we consider to be insignificant might have a huge impact on the way our planet works. Ultimately, this probe's all about closing the gap in our knowledge about the effects of dust on our planet, because the mineral dust blown into the atmosphere might have more effects than what was previously known. So by accurately mapping the compositions of the areas that produce mineral dust, EMIT will help us understand the effects of the dust throughout our system and its impact on human population today and in the future.